All right, welcome back to another exciting edition of Math from Home. I know you guys are probably thrilled. Today, what we're going to do is we're going to do lesson 3 of the sequences and series portion of Unit 4. This is also in your notes as lesson 4.567, I believe. So we're actually going to do lesson 3 and 4 today because lesson 3 is super short. So we're just going to combine them together. Today, what we're going to do is we're going to do geometric sequences, which is lesson 3, and geometric series, which is lesson 4. In the previous 2 lessons, we did arithmetic sequences and arithmetic series. The difference being between a sequence and a series is a sequence has comma in between numbers, a series had additions in between numbers. So one was adding and one was just listing numbers. Today we're going to do sequences and series again, but now they're going to be geometric. Geometric means that instead of adding or subtracting to get numbers, we're going to be multiplying to get the next number in line. Okay, that's the difference. Let's jump into it. So what is a geometric series? This right here is a geometric series. The difference between geometric and arithmetic is when you get from one number to the next, you're actually multiplying by something. In this case, we're multiplying by 3 every time. Where with arithmetic, we were adding or subtracting to get the next number. This means we no longer have a D value. We now have an R value for a ratio. That's what you're multiplying by. My advice to you, because we're going to have a lot of formulas by the end of this unit, right? Try to figure out if you have an arithmetic or a geometric question. If it's an arithmetic question, then you'd be using a D value and you're using one of your formulas with the letter D. If it's a geometric formula, then you're going to be using one of your formulas that has an R. And that's my advice. Okay, the way that you figure out R is by taking one of the numbers and dividing it by whatever number's in front of it. So for instance, if we took the number 3 and we divided it by the number in front of it, which is 1, it would give you R, which is 3. And we can do this over and over again. So if you took 9 and divided it by the number in front of it, it would be 3, which equals your R value, which is 3 again. And we keep doing it. So if we have 81, divide by the number in front of it, 27, it equals 3 again. So the way you find your R value, if it's not obvious, is take one number, divide it by the number in front of it, and that will tell you the ratio you're going up by. Our first formula we're going to use is to help us figure out terms, the nth term. So we're going to use this formula right here. Let's try applying it. So this question says, find the 7th term in the sequence. We're looking for T of 7. To do that, the first thing we need to know is what T of 1 is. T of 1 is 4. So we have 4 times. Then we need to do R. Our R value equals pick a number. Let's pick 16 and divide it by the number in front of it. So for us, our R value equals 2. So we have 4 times 2. I'm going to put that 2 in brackets. To the power of n minus 1. We're looking for the 7th term, so it's 7 minus 1. You're going to want to put that in your calculator. When you do that, you get that T of 7, the 7th term, equals 2 to the power 7 minus 1. I want you to try that right now. Make sure you're doing 2 to the power of 6, right? You don't want to do 2 to the power of 7, get 128, and then subtract 1 from it. Instead, you want to do 2 to the power of 6, because that's what 7 minus 1 equals. And then multiply that by 4, and you get 256. So your 7th term is 256. Awesome. Let's try another one. The series are a little harder, so we're going to go quick through the sequences. This says, find the number of terms n in the following sequence. Okay, we're looking for n. This is geometric. I know it's geometric because when I look at the numbers, they're not just adding, right? If I look to get from 6 to 12, I multiply by 2. To get from 12 to 24, I multiply by 2. So that tells me this is a geometric sequence because I'm multiplying, not adding or subtracting. Our goal is to figure out the nth term. We're going to use our formula. Our formula is t of n and then t of 1 times r to the power n minus 1. We're going to fill in everything we know. T of n means the last term, so it's negative 192 equals t of 1. T of 1 is negative 6. Negative 6 times r. R in this case we already figured out was 2 to the power of n, which we don't know, minus 1. Okay, this question is going to be a little bit tricky. So our job is to figure out what n is. So we need to somehow get n by itself. The first step is going to be getting rid of that negative 6. I do that by dividing negative 6 to the other side. That gives me negative 192 divided by negative 6 is 32. So I have 32 equals 2 to the power of n minus 1. To solve that, when you're looking for the exponent, we don't have a way to get exponents by themselves. If you're interested, you could Google something called a logarithm. A logarithm will tell you how to solve for an exponent. That's a whole unit of its own. We learn it next year in grade 12. For now, all we're going to do is we're going to do basically a little bit of guessing and checking. We're going to ask ourselves, 2 to the power of what would equal 32? And we're going to try things. So if you do 2 to the power of 4, it's 16. 2 to the power of 5 is 32. So I know that 32 equals 2 to the power of 5. That means that this exponent up here, n minus 1, must equal 5. The only way that could happen is if n equaled 6. So you're just basically guessing and checking to figure out what exponent would work, and then you use that knowledge to figure out what n is. Awesome. Let's do geometric series. So geometric sequences means there's no additions, it's just commas in between. Geometric series is now we're going to have addition signs in between, right? Here's the difference. Geometric sequence, geometric series. Only difference is adding, not adding. The first formula we're going to use for geometric series is this guy right here to help us add up all the values in a geometric series. We already kind of know what everything means. S means sum, n means the last term, t of 1 is the first term, r is the ratio that you're growing or shrinking by. We have n, that's the number of terms, and that's about it. So let's jump into a question. This one, for the geometric sequence, -5, 10, -1, or sorry, -20, ... write the sequence as a series. To write a sequence as a series, we just have to put addition signs. So we're doing the same thing, but now it's plus. That's the only difference, is that there's a plus sign. Determine the sum of the first 15 terms. To figure out the sum, we're going to have to use that sum formula, which is S of n equals the first term times r to the power of n, subtract 1, divided by r minus 1. So let's try that formula. We're looking for the sum of the 15 terms. The first term is -5. We're going to multiply that by r. To calculate r, you take a number. Let's take 10 and divide it by the number in front of it, which is -5. That will tell you r. In this case, it's equal to -2. So we have -2 to the power of n, which is 15, minus 1. Notice that your minus 1 is now not in the exponent, right? So in the previous, if you look at this one, the minus 1 is not in the exponent. If you look at these formulas, the minus 1 was in the exponent. Right? Be very careful of those minus 1s when you're calculating things. And then divided by r, which is -2 minus 1. I'm going to calculate this in chunks. So I have -5. I'm going to calculate inside those brackets. Make sure your -2 is in brackets. So -2 to the power 15 equals -32,768. Then we're going to -1 from that. So we have -32,769 divided by -2 minus 1 is -3. Put all that in your calculator. You have -5 times that divided by -3. The sum is -54,615. You're going to notice that your sum values for these questions are actually quite large. The reason they're so large is because ratios get big really fast. And we're multiplying by -2 every time. Our numbers get fast really quickly. So that's why you're going to notice your sum values get quite big or quite small. Okay. That's a geometric sequence turned into a geometric series and then calculated to figure out the sum of that geometric series. This one says determine the sum of the series. On the right-hand side, you'll notice that we have one of our formulas right here. We've already seen that one before, and now we have a new one, this guy. Both calculate the same thing. One of them requires you to know t of n. One of them does not require you to know t of n. So it's your choice on which one you want to use. This question says, determine the sum of the series, and they give me t of 1, which is 64. They give me t of n, which is 729, but they never tell me what n equals. Because they never tell me what n equals, then I don't want to use that formula because that formula required me to know n. This formula I would want to use because it does not require me to know the value of n, only the value of t of n. So we're going to go ahead and we're going to try using that formula. That formula said that the sum of a series equals R. R is take a number. Let's take 96 divided by the number in front of it, which is 64. In our case, R is 1.5. So we have 1.5 times t of n. T of n is our last term, which is 729. Minus our first term. Our first term was 64. Divide all that by r, which is 1.5 minus 1. Again, I'm going to calculate this in chunks a little bit. So I'm going to do the top first. I'm going to go 1.5 times 729 minus 64. To get that, my top value is 1029.5. On the bottom, 1.5 minus 1 is 0.5. Put that in your calculator, and you'll find that the sum of those first however many terms is 2,059. Like that. Awesome. Now you have two sum equations. So let's try some more questions, and you get to pick which one is which. So it says, in a geometric sequence where t of 5 equals 1,024 and r equals 4, find the sum of the first 7 terms. Okay, to be able to do this, you're going to have to choose one of these two formulas. The first formula requires you to know t of 1, requires you to know r, and requires you to know n. Looking at our question, we know r is 4, we know n is 7, but we do not know t of 1. The second question, or the second formula, requires you to know r, which we know, requires you to know t of n, which we do not know because we don't know the 7th term, and requires you to know t of 1, which we also do not know. So for me, because I don't know what t of 7 is, and I don't know what t of 1 is, I think it's probably easier to use that formula than that one. Because the top one only requires me to find one thing, t of 1. The second one required me to find t of 1 and t of 7. Seems like too much work. Okay, figuring out what t of 1 equals. To figure out what t of 1 equals, You have a couple different strategies. The strategy I would utilize is realizing they gave you some info here. They gave you T of 5, kind of like a random term. So what I would do is I would go to our term formula, which said T of n equals the first term times r, and then n minus 1. And if I fill everything into that except for T of 1, I should be able to calculate this. So T of 5 is 1024. That equals the first term, which I don't know, times r, which is 4, to the power of n, which was 5, minus 1. That means 1024 equals the first term times 4 to the power of 4, which is 256. If we divide that to the other side, (1024) divided by 256 equals 4. So the first term is 4. Now I can go back and use this sum formula because I know T of 1, I know R, and I know N. So let's do that. I'm going to do it in different colors so it kind of stands out. Let's do it in red. So the sum of the first 7 would equal the first term, which we just found was 4, times R, which is 4, to the power of N, which is 7, and then subtract that by 1, and divide it by R, which is 4, minus 1. I highly recommend you do this in chunks. So 4 to the power of 7 equals 16,384 minus 1. That means I have on the top 4 times 16,383 divided by 4 minus 1 is 3. If you do that, you should get that this first 7 terms added together equals 21,844. That's the first 7 terms added together. That's a trickier question, right? We had to go calculate something to be able to do the rest. Okay. We got this question left here. I think 2 more, right? Yep, 2 more. Maybe pause. See if you can do this one. It's a hard one, but pause. Give it a try. See where you get stuck. The trick is usually finding the right formula and then how to find things that are missing, but give it a shot. All right, hopefully you did that. You paused. You took a shot at it. This says in the series 5 plus 15 plus 45 plus blah, 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 plus 10,935, which term is 10,935? Determine the sum of that series. Okay, they're asking you which term. This is a kind of 2-part question. Which term is 10,935? They're asking you, what does n equal to get 10,935? The first thing I'm going to do is I'm going to realize they're asking me for n. They've given me T of 1 equals 5. I can figure out that R equals 3 just by looking at it. I'm like, to get from 5 to 15, we times by 3. To get from 15 to 45, I times by 3. And they've given me that T of n equals 10,935. Quick look at my formula sheet, and I'm like, hey, they've given me most of the information for this formula. T of n equals T of 1 times R to the power of n minus 1. So I can fill in everything in that formula sheet except for n. So let's do that. This gives me 10,935 equals 5 times 3 to the power of n minus 1. I'm going to try to get that power by itself by dividing both sides by 5. If I divide both sides by 5, 10,935 divided by 5 is 2,187 equals 3 to the power of n minus 1. Again, we don't know how to solve for powers, right? I'm just going to guess and check. I'm going to try a few things, right? I'm going to go 3 to the power of, let's try 5. If I calculate 3 to the power of 5, I get 243. If I try 3 to the power of 6, 3 to the power of 6, I get 729. If I try 3 to the power of 7, I get 2,187. So that tells me that this must be 7. The only way that's 7 is if n equals 8. So that's the answer to the first part of my question. 10,935 is the 8th term. Okay. Now, let's try to determine the sum of the series. To figure out the sum of the series, you can use either one of these formulas. The first one requires you to know the first term, which I know, the r, which I know, and the n, which I know. The second formula requires you to know r, which I know, t of n, the last term, which I know, and t of 1, which I know. So it's really your choice on which formula you want to use. I'm going to use the top one. No real reason, just going to. So s of n equals t of 1, r to the power of n minus 1 divided by r minus 1. I'm just going to fill that in. The first term is 5. R was 3 to the power of n, which is 8. And then subtract 1 divided by 3 minus 1. Again, I'm going to calculate that in chunks. So I'm going to figure out what the inside of the brackets equals. 3 to the power of 8 is 6,061. When I subtract 1, I get 6,560. In the denominator, I have 2. Now we can calculate the whole thing. So 5 times that. 5 times 6, 560. And then divided by 2. You get the sum of the first 8 terms, which I guess I could have been putting 8 here instead of n. My apologies. Sum of the first 8 terms equals 16,400. Fantastic. Hopefully you did pause and try that one on your own because it was one that was doable. You're going to notice that this unit is a lot of formulas and just figuring out which formula to use where. Again, my advice to you is figure out if it's geometric or arithmetic. These are geometric because I have R values, right? That means I have to use one of my R value formulas and then just try to narrow it down from there. This one right here. Find the number of terms in a series if S of n equals, and that actually isn't equals. That's like approximately equals 3,449.07. That means they must have done some rounding somewhere. They've told me the first term. They've told me R. So my job is to look at the formulas and figure out which one would tell me the n value, because that's what I'm looking for. Find the number of terms. If I look, the only formula, actually, let's look at these two formulas right here so I don't have to write them out. My two formulas are right here. I'm looking for n, which means that the second formula actually wouldn't be any use to me right now because there is no n in that formula. The one above might be useful to me if I know what S of n is, if I know what T of 1 is, and I know what R is. In this case, I do know T of 1, I do know S of n, and I do know R, so that's the formula I want to utilize. That formula is S of n equals T of 1, R to the power of n minus 1, all divided by R minus 1. If you haven't tried this question, now that I've told you which formula to try to use, try the question. Okay, so pause the video right now, give this question a shot. Perfect. Hopefully you did that. We come back to this. We're going to fill in everything we know. So we know S of n is 3,449.07 approximately. That equals the first term, which is 29, times r to the power of n. So we have 1.07 to the power of n, and then subtract 1. In the denominator, we have 1.07 minus 1. Okay, calculating this. Going to be a little bit tricky. So I'm going to figure out what the denominator is. The denominator is 1.07 to the power of n minus 1 is 0.07. All right, so if I did 1.07 minus 1, that's what I get. My goal now is to get n by itself. Since n is an exponent, I'm really just trying to get the power by itself. To do that, I'm going to have to multiply both sides by 0.07. Like that. So I put that in my calculator. 0.07 times 3449.07 gives me 241.434. And that's equal to 29 times 1.07 to the power of n minus 1. I'm going to divide both sides by 29. When I do that, my number continues to get messier. So I have 8.32534139, and that is equal to 1.07 to the power of n minus 1. To get that power by itself, I'm going to add 1 to both sides, and I get, just going to draw a line here, I get 9.32534139 equals 1.07 to the power of n. Okay. We're trying to figure out n. To figure out something that's in the exponent, we're just going to try guessing and checking. And this is going to be tricky. The reason it's going to be tricky is because we have some crazy decimals here. We're trying to figure out what value of n would give this. We're just going to have to guess and check. So let's try a number, and let's try like 1.07 to the power of 10. If we calculate 1.07 to the power of 10, I get 1.967, blah, blah, blah. I'm still quite a ways away. Sorry, my computer is very glitchy right now. 1 point, blah, blah, blah. There we go. I'm still very far away when I did to the power of 10 to getting my answer of 9.353. So I'm going to try a much bigger exponent. I'm going to try like 15. So 1.07 to the power of 15. We'll see what happens. 1.07 to the power of 15. And I get 2.759, blah, blah, blah. I'm still quite a ways away. So I'm going to try 1.07 to the power of, let's do 19. If I do 1.07 to the power of 19, I get 3.616, blah, blah, blah. And you can kind of start to see, like, I went up a lot and I'm still not even close. So I'm going to, instead of going up just a little bit, I'm going to go up a lot more than that. Let's go up by 1.07. I don't know. Let's go up by like 30. Actually, let's try 35. When I do that, 1.07 to the power of 35, I get 10.67, blah, blah, blah. Okay, I'm getting closer, but now I'm a little too big, so I'm going to have to do a smaller exponent, 1.707 to the power of 34. If we try that, actually, let's try 33. 1.07 to the power of 33. 1.07 to the power of 33 equals 9.3253397. And you notice we have found what works. These numbers aren't exact. They are for a long time, right? 9.3253 is all the same, but then the final little numbers change right here. The reason why is because this was an approximate question, right? They rounded at some point. So our answer is close, but not perfect. However, I now know that n must be 33. So that is my answer. There's 33 terms in that series. It took some guessing and checking, which isn't the best, but hey, it worked. There is, you might have learned in Math 10 how to use your calculator on how to find exponents or values like that a little quicker. If you did learn that trick, feel free to use it. The only problem is I can't really show you what's on my calculator. So it's kind of a difficult trick to show you without being able to work with your calculator right in front of you. So we're just using guess and check. It's kind of the best way to do it right now. Awesome. That finishes our thrilling COVID-19 lesson on geometric series. Take care. Hope to see you soon.